In this video, we're going to solve the 1999 AP Calculus FRQ question number 1. It's a calculator question because it's 1 or 2 or 3. Before 2007, I believe it was 1, 2, 3, but it's 1 or 2, so it's definitely a calculator question. So it says, a particle moves along the y-axis with velocity given by v of t equals t sine t squared for t is greater than or equal to 0. In which direction, up or down, is a particle moving at time t equals 1.5? Why? Okay, so this is a pretty easy, straightforward question. So for part A, all you have to do is v of 1.5. You literally take your calculator and you plug it in. And you plug it into this function. And you could show this. And now when you do this on your calculator, you're going to get 1.167. So this has to be moving up because it's greater than 0. So you just say v of 1.5 is greater than 0, therefore moving upward. Okay, part B. Find the acceleration of the particle at time t equals 1.5. Is the velocity of the particle increasing at t equals 1.5? Why or why not? Okay, so also a pretty straightforward question. You're going to do a of t equals, and this is going to be, the derivative of this is going to be a product rule. So derivative of t is 1, so you're going to get sine t squared. Now you have to take the derivative of sine t squared. So derivative of sine t squared is cosine t squared, but you have to take the derivative of t squared, so that's 2t times the original t that was there. So now, simplifying this, a of 1.5 equals sine of t squared plus 2t squared cosine t squared, and use your calculator as well. T equals 1.5. I use x instead of t. And when you do this, you're going to get negative 2.049. So v is decreasing at 1.5 because a of 1.5 is less than 0. Okay, part C. Given that y of t is the position of the particle at time t, and y of 0 equals 3, find y of 2. Okay, so 0, 3 is our initial condition. So now we're going to have to do integration. So we have y of t is going to equal the integral of the original function. So we're going to have to do u sub dt, and technically this needs the parentheses. So let me zoom out a little bit. Okay, so let u equal t squared. So du is going to equal 2t dt, or du over 2 is going to equal t dt. So now we have y of t is going to equal the integral, pull the 1/2 out, and now we have sine u du. Okay, so what's the antiderivative of sine u? That's going to be negative cosine u. And we have the 1/2, so we have divided by 2 plus c. Okay, plug it into 0, 3, so this is y now. So now we're going to get 3 equals negative cosine of 0 divided by 2 plus c. Cosine of 0 is 1, so it's 3 equals negative 1/2 plus c. The same thing as 6/2, so c has to equal 7/2. So now back to our original, or back over here, we could say y equals negative cosine of, now we could say 2t, right? T squared, back to the original, over 2 plus 7/2. Okay, and now we're going to need a calculator, and we could plug in, what was that, 2? Y of 2? So y of 2, plugging it into this function, and t equals 2. When you do this, you're going to get y of 2 equals 3.827. Okay, now let's look at part D. It says find the total distance. Okay, so that's easy. If it was by hand, you'd have to figure out where there could be a min or a max, but in this sense, it's pretty straightforward. You just do total distance is going to equal, let me put box over here, the integral of the absolute value of v of t dt. So use your calculator, TI-89, use int, absolute, type in the function, t sine t squared, close, close, comma t, comma 0, comma 2, said 0 and 2. When you do this, you're going to get the total distance is approximately 1.173. Actually, I think it was straightforward. I don't think it was approximately. I think it was actually that number, and no, it's approximately. Okay, I hope this video helped, and I'll see you guys next time.